Hi viewers, I'm Hassan. I'm here to give a presentation on ship stresses. So let's begin. So as we see, there are three axes: x-axis, y-axis and z-axis. So as we see, on the x-axis there are surge movement, which one is called forward and backward, and on the z-axis there are heave movement, which one is called up and down, and on the y-axis there are sway, which one is called left and rightward movement. So that one goes the translational movement. So another movement is possible, which one is rotational movement, which also occurs on three axes: rolling, pitching and weighing. So if we sum up these two together, we can find that a ship has 6 degrees of freedom. So now I want to talk about stress and strain. So I'm gonna give you a simple brief on stress and strain. So stress is the amount of force per area, and on the strain there are distortion due to stress. This usually expressed as percentage. So as we see in the stress table, so we see the tensile stress, compressive stress and the shearing stress. So the stress also divided into two parts: static and the dynamic. Static is a stationary stress and dynamic is a moving stress. So there are transverse stress, which actually occurs along the breadth, longitudinal stress, which one occurs along the length, and there are some specific area which actually give some stress, which one is called localized stress. So this presentation I'm gonna tell about water pressure, racking, torsion, dry dock, shear force, bending moment, painting, pounding, heavy weights and so on. I want to give idea about parts of waves. So let's see. So the top of the wave is called wave crest, and the bottom of the wave is called the wave craft. So the forward of the ship is called forward or fore, and the behind of the ship is called aft, and the middle of the ship is called amidship. So there is a upward force on the forward, another upward force on aft of the ship, and one downward force is on amidship, which cause a sagging. So as you see again, there are downward force acting on aft and downward force on forward, and there are upward force on amidship, which cause hugging. So as you see the dynamic, here we go. So you see the sea wave here. So the wave crest is on amidship and wave craft is on forward and the aft on hugging. So sagging is completely opposite of hugging. So as you see, the wave crest is on forward and aft, and the wave craft is on amidship. So which one cause sagging? So as you see example of hugging, you see the keel is on the compression and the deck is on the tension, and here you see the keel is on the tension and the deck is on the compression. So this one is hugging, the first one, and the second one is sagging. So let's talk about longitudinal stress, which in actually a shear stress. As you see, this one is a ship and there is two downward force and one upward force, and which one actually if we can make a shear force diagram and bending moment diagram, we can see clearly the shear force on this body, which is our ship here. As you see, there are heavy weight acting downwards and another heavy weight acting downwards, and in the middle there are some lightweight acting upward, so which actually creates a shearing force. Let's talk about transverse stress. So first of all is water pressure. Pressure is increased with depth, so the greater the draft, the greater the pressure on the ship's side and bottom plating. As you see here, this is a ship, so the water is all around the ship. So the water tries to squeeze the ship's plating and the bottom part of the ship. That's actually gives transverse stresses on the ship. So another one is dry dock stress. So this is completely opposite. When the ship is on the dry dock, it actually takes out all the water and it tries to moves outward, and there are only block which one is supporting the ship, so which actually take out some pressures from the side plating, and it tries to move outwards and remove, because of it has removed from the pressure, so it tends to do like that. So as you see, this one is example of transverse stress on dry dock. Okay, the next thing is racking stress. So when a ship rolls in a seaway, the waterline is not horizontal, and the center of the buoyancy continually moves to the continually changing center of the underwater volume, which will probably not to be on center line. The thing is, this is the center of the gravity and this is the center of the buoyancy. When this center of the buoyancy and center of the gravity is not in the center line, the ship's hull tend to be diamond shaped, so that's actually caused the racking stress. So the effect can occur due to dynamic forces also. So the waves and the soil hitting the side of the hull can push the hull and try to make a diamond shape, so that's actually the racking stress. So as we see here, we do have a figure which actually tries to give an idea about racking stress. As you see, so it tries to make diamond shaped, so this actually calls the racking stress. So another one is panting. Panting is nothing but in and out movement of the ship. So ship's hulls actually go up and down, and the pressure, the stress actually continually changes, so it actually happens on the forward of the ship. So as I can show you here, the ship can move up and down, so which actually called panting. Another stress is called pounding. So this is the slamming down of the ship's bottom plating near the bow. So it actually happens on rough weather, and also if too much trim is there, or less number of ballasting is done, so it can be happened in those cases. So as you see, this ship's bottom plate actually slams on the sea. So I'll try to give a figure. As you see, this ship's bow, which is the forward of the ships, actually slams on the seawater, which actually gives a pounding stress. So pounding stress, ship's point of view, this is a real case scenario where the pounding is happening. As you see, the forward of the ship is moving upward, and it slams on the seawater. Another transverse stress is happens due to heavy weights. Maybe the ship structure need to be so strong and take the strength if the additional crane is added on the ship, or heavy weights are added on the ship so that it can also create some stress. Also due to the main engine, which also can create some transverse stress. So as you see, the bottom plating is in the stress, and also here two heavy loads on the port side and starboard side is added, and the ship's keel is under stress, and this one is normally a representation of the main engine, which is tend to install on the center of the hull, center line of the hull. So another one is another example. As we see, there are extra strength can be provided by shoring deck. As you see, some of the structures which actually gives additional stress to the ship's hull. So another thing is stress concentration. So any section or material is containing a notch, such as a hole or cut or bend or change in shape, will suffer an increase of stress around the section when it is placed under a load. Thank you for your time. I hope you enjoyed the presentation, and see you soon. Stay home, stay safe. Thank you.